Namaste. Today we are going to discussing about important points from S block elements. Now, S block elements means the differentiating electrons entered into the s orbital of valency shell are called S block elements. The S block elements present at left side of the periodic tables. S block elements present at left side of the periodic tables. S orbital can accommodate only two electrons. Only two electrons. Okay, the S block elements containing two groups. One is first A group, second A group elements. First A group elements like lithium, sodium, potassium, rubidium, cesium and francium. Second A group elements like beryllium, magnesium, calcium, strontium, barium and radium. So in first A group elements, francium is radioactive elements. Here in second A group elements, radium is radioactive elements. First A group elements and second A group elements belongs to the S block elements. So S block elements are highly reactive metals with low ionization energy. Okay, the general electron configuration of S block elements is Ns122. Here N is the number of valence shells or number of energy shells. In S block containing two groups, one is first A group, first A group containing lithium, sodium, potassium, rubidium, cesium and francium. Francium is the radioactive elements. Okay, these elements are also called as alkali metals. Why it is called as alkali metals? Because hydroxides of first A group elements reaction with water. That's why it is called as alkali metals. First A group elements also called as alkali metals because of their hydroxides reaction with water. Okay. Here alkali metals in alkali words derived from Arabic word. That is alkuli. Alkuli means ashes of plants. ashes of plants. The S block elements also containing secondary group elements. Secondary group elements. The secondary group elements like beryllium, magnesium, calcium, strontium, barium and radium. Radium is a radioactive elements. Except beryllium, the rest of the elements also called as alkali earth metals because of their oxides and hydroxides are alkali in nature and their oxides are found in earth crust. That's why we are called alkali earth metals. Secondary group elements also called as alkali earth metals because of their oxides and hydroxides alkali in nature and their oxides are found in earth crust. That's why we are called alkali earth metals. Now we are going to discuss first A group elements. First A group elements. Is also called as alkali metal. First A group elements like lithium, sodium, potassium, rubidium, cesium. Lithium, sodium, potassium, rubidium, cesium belongs to first A group elements. Its general electron configuration is ns1. Here n represent number of energy shells. Here 1 represent valency electrons. That means only one electron should be present in valency orbit. That's why it loses electron readily to form monovalent ion like M plus ions. Alkali metals lose electrons readily to form plus 1 ions. Alkali metals are highly reactive metals with low ionization energies. Okay. Now we are going to discuss about properties of alkali metals. Now we are going to discuss properties of alkali metals. First property, atomic radius. Atomic radii or radius. What is the atomic radius? Look here. This is a nucleus, center of the nucleus of atom. Nucleus. Electron present outermost orbit. This is the outermost orbit. This is the distance. The distance in between center of the nucleus and outermost orbit of electrons is nothing but atomic radius. Down the group, atomic radius increases. Down the group, atomic radius increases. That means from lithium to Cesium atomic radius increases with increased number of energy shells. Okay, look here, atomic radius order: lithium, sodium, potassium, rubidium, cesium. Down the group means like this: lithium, sodium, potassium, rubidium, cesium. From top to bottom or down the group, atomic radius increases. That means we put less than. Due to number of energy shells increases. One single is in here. First property, atomic radii or atomic radius. What is the definition for atomic radius? The distance in between center of the nucleus and outermost orbit of electrons is nothing but atomic radius. Atomic radius of alkali metals from lithium to cesium increases with increased number of energy shells. Okay. Second property, density. Do you know that density is equal to mass by volume? Mass by volume. Look here. The order of the density for alkali metals is lithium less than, potassium less than, sodium less than, rubidium less than, cesium. This is the order for density of alkali metals. And third property, ionization energy. IE or IP. Ionization potential or ionization energy or ionization enthalpy. The ionization energy of alkali metals from lithium to cesium decreases. That means down the group ionization energy decreases. Look here, order: lithium, sodium, potassium, rubidium, cesium. Down the group ionization energy decreases due to two reasons. One is atomic size increases down the group. Atomic size or atomic radii increases down the group. Increases down the group. And second reason is decrease nuclear attraction. Decrease nuclear attraction. Decrease nuclear attraction on the outermost orbit. Due to these two reasons, ionization energy decreases down the group for alkali metals. Fourth property, electron negativity. Electron negativity. EN. Electron negativity. Alkali metals have low electron negativity as compared to other elements. Alkali metals have low electron negativity as compared to other elements. The electron negativity decreases from lithium to cesium. Lithium to cesium. Lithium to cesium. Look here. Lithium greater than sodium, greater than potassium, greater than rubidium, greater than cesium. This is the order for electronegativity of alkali metals. Because due to first reason, increase atomic radii down the group. Second reason is decrease nuclear attraction on the outermost orbit. Third reason is increase electropositivity nature. Electropositivity nature. From lithium to cesium. This is about electron negativity. Okay. Fifth character, electropositivity. Alkali metals are highly electropositive in nature. Alkali metals are highly electropositive in nature. So electropositivity increases down the group. That means metallic character also increases down the group. Metallic character increases down the group. So one second listen. Electropositivity of alkali metals increases down the group. That means metallic character also increases down the groups. So when metallic character increases down the group means reactivity of alkali metals increases down the group. Reactivity of alkali metals increases down the group. This is about electropositivity. Sixth property, oxidation state. OS. Alkali metals shows +1 oxidation state. Alkali metals shows +1 oxidation state due to low ionization energy. Alkali metal shows +1 oxidation state due to the low ionization energy. Look here. Alkali metals can readily lose the electron from outermost orbit to form unipositive ions. That's why they can show the +1 oxidation state. It can represent M+1. M means here alkali metals like lithium, sodium, potassium, rubidium and cesium. Okay, now alkali metal ions are colorless. Alkali metal ions are colorless, and it can show diamagnetic in nature. Alkali metal ion shows colorless compounds, and alkali metal ion diamagnetic in natures because paired electrons present in outermost orbit. Outermost orbit. In here, alkali metal shows +1 oxidation state because of low ionization energy. Alkali metals can readily lose electron from outermost orbit to form the unipositive ions, which is represented M+1. M means alkali metals. So these ions are colorless and diamagnetic in natures because of paired electrons present in outermost orbit. Seventh property, hydration enthalpy or energy. So here one relation is that hydration enthalpy and atomic size both are inversely proportional together. So size of the ion is inversely proportional to hydration enthalpy. Hydration enthalpy. Look here. Larger the size of ions, lesser hydration enthalpy. Lithium ion, sodium ion, potassium ion, rubidium ion, and cesium ions. So the order for the hydration of enthalpy of alkali metals is okay. So this is today our session. Thank you.